Okay, now we created the data, which is a very important step in our process and on solving equations using DeepONets, because we need the data to train the models. But as you know, the problem is these data so far is just like a NumPy array, as we can see here. And we need a bit more. We need these data to be in a shape that we can use for training DeepONets. So let's step by step change these data into the form that we need to use for our training process. So the first thing is what we do is we uh, basically have to change these data's shape to match the DeepONets library, or not library, I would say the DeepONets input shape, and it's a bit tricky. It's a bit specific. So let's go a little bit to the paper related with DeepONets and or deep neural operator or operators net. And in this paper, we can see it is made by this guy, Lulu, and I think he's maybe Chinese, I'm not sure, but this guy is actually, you can find lots of or some code related to pins, especially. And some, I would say, DeepONets you can also find. Now this guy is also, you can find him in YouTube. You can just type his name, and there are some lectures for him. You can just you can see it. And this guy is I didn't see him in the internet, but these two are like quite familiar in the web, in the internet. So you can see here the universities, mainly in the US and Brown University, and I think there is some collaboration with the Chinese Academy of Science. As you can see here, what we care about is how these things work. We already know that using data, we can somehow predict these networks, or build a neural networks to predict our values. But the way it works, or the data, has to be in a way that first we need to add the whole input sequence. So for our case, we're doing integration, so we need to put the whole u sequence, the whole curve that we have, that is this curve, the the orange curve. We have to put all its data into the network. So this is this part of the network, and in here our Mr. Lulu and Mr. I think he's Greek, George. He's they call it branch, or the first branch. Of course, we can call anything, but it's mainly they call it branch, and the other thing they call it a trunk, or trunk net and branch net. So what happened is we take this, all the U's, and then we put them into a neural network. And this is how we teach, or this is going to be the first part of the network, which is the branch. The other part is the trunk, and the trunk, we put the exact location in which we are trying to solve. So we will put, let's say we interested in UX2, so we put the whole thing here, and then we put only one part, which is the value itself, just one value, into the trunk network, or the other branch network. And then we perform this multiplication, and we will talk a bit more about this multiplication, and until we get the actual result. So or I would say this unstacked deep nets, what we will apply. The first thing, we will put the whole U, and then put it into a branch net. We get some way, like we get some neural points from the whole input, and then we take the y value of the place we are trying to solve, and then we simply will get another neural values through this trunk net, and then we multiply it into each other. This kind of architecture is called unstacked deep nets. Of course, here he's showing some other way of doing it, like putting we take the whole thing and put it in different neural nets. So basically we'll do this version, and this is the new thing about these networks. This is where the smart idea about how to handle solving an ODE or ordinary differential equations, that we put the neural network will already know all the input sequence, the whole U, and it's going to know what is the point you are trying to solve. So for example, this one. Now, this is what we refer to in our network is U. This is going to be the whole thing that we said we will put. So the what is it? This one, and the exact location of U is going to be another input, which is just this location, and the other one in the other side of the network that we are going to solve our neural network, or we're going to train our neural network to evaluate, is the S, which we create in here, which is the integration. So where is this guy? This is the S, yeah, which is the actual integration of the thing, like the curve, the whole curve. So we keep pushing our values, first this one, and then we push also this point, and then we evaluate this point, and then we push another point into the network and evaluate another one. So in order to actually solve the whole curve, we don't do it one time. We have to keep activating the network, or keep asking the network what is the valuation at every point in the whole sequence, in the whole network. Well, in this case 100 times, because you said we have 100 times. These things will be a little bit more clearer as we go. So the first thing we need is to change, as I said, the shape, and this time the shape will be as we said, every training point will have the whole sequence and only one point of the in which we are trying to evaluate, and the corresponding solution of S. So we need to change this network. We already have said that we have an M of 100 points, and N is 110, means we have 110 data samples, and we have 100 points of the whole curve. So what we do is, if we multiplied 100 multiplied 11 112, it will be 11,000, because like 1 and 3 zeros, and means we have 11,000 data points. But we need to input the whole curve, the 100 points, and every curve will have an every point of evaluation will every point of data will have 100 points to be a data point. So the first thing we need is to define. So what we expect is U has to be in the shape, or yeah, we call it, let's say, so U solver has to be in the shape of 11,000, or M multiplied by N, which in our case equals 100 point multiplied, or 11,000, basically data points. And this has to be basically the shape of US has to be 11,000 point, but we need to add it as 100 point. This is the whole curve. This is the first input, which is in the branch network. Here we can see here 100 points. So this is going to be the 100 points, the whole thing. Now, on the other hand, we have XS, which is, like it just X. This is going to be it is just the X. So we have 11,000 point, but we are going to be only 1. Why we say 1? Because we will add this point to the trunk network to tell it where I want to find the integration value, So the network knows, I know the whole curve that we need to integrate, and I know where you want to do the integration. So this is the input curve, this is the location you want to integrate. So has to be known. And the last thing is, of course, you need to train these things. So in order to train these things, just make it like this. We need a corresponding answer. And the corresponding answer means, well, you need to add S. So you have the input, the whole curve, this one. You have the input point in which you are trying to find the answer. And that, at the end, you have the corresponding answer. So this is going to be S. So let's make this happen from all of these, or from U, X, and S. So of course, maybe X also you can put the actual value of U, but I prefer X. It is shows exactly where the point is. You want to show the network where you want to perform the integration. So there are many ways to do this kind of thing, but I prefer X. So def iterate data, you can name it anything you want, and then you have M, just a little, and you have N equals N. I forget the M means 100. Just take this kind of thing, just you can put it just here. Of course, we don't need to redefine it, just we want to remember M equals 100 points, N equals data. So you need a function to do this kind of reshaping. M equals the 100 points, N equals 110 points, and then what do you need? You need X equals X, you need X, you need U, capital U, as we assigned before. It's capital U, and S also capital S, and S. Yeah, so these are the things you need to add in order to reshape the data. So the first thing is US will equal numpy array and zeros. What is the shape? We said N multiplied M, or M multiplied N is the same. And how many data points? 100. M, the whole number of the curve. This is going to be the input, and it's going to be repeated in multiplied N. This is 11,000 points. So this is US. Now the XS is going to be also the same here, but here we need it only 1, because we say to the network we need to find the location in this, we need to find the solution in this location only. So XS, and SS, this guy, same thing, 1, nothing different. This is now, of course, these are 0 matrices. We need to change it a bit, and to change it a bit we need 4i in range of n. This is basically the number of data points, and j in range of what? Of m. the whole data points. And then you need US, or like we can put it, this is a counter, like we can start by, like, we can add two things, like we can add here counter 0 and it will count the data, or we can let's put it a little bit different way, m plus I. So what does it mean? This one is basically it will take the first data point, and then this will be counted from 0 to, in this case, 99, and is going, this is why we added 1, and this will start to populate these, the US, the location of US, and well, everything here, basically the whole row, or the whole column, because every row, it kind of, it will be the data point, or the data the input, the data sample, the one data sample, and it will have the whole u values. So it will equal to u everything at, remember, u, this is the whole graph, and this is the data point. So related to I, this data point. So this is, we added the whole graph into this guy here. So xs, xs will be equal to, this is going to be the same, but here is okay, we can put it like this, because we actually only have one location, but maybe we can put it also 0, but let's be like everything in this location will be related with x at the j location, because we need xs for this data sample. Of course, everything will be u for that I. J has to be depending on only, it will repeat 0 to 100 to 99, and then repeat 0 to 99, and repeat 0 to 99, and so on. So we have to keep this one as is, and this one, well, not xs, this ss, and this time we have to be, of course, the same thing, we're just everything here, but here is a little bit different. Now s will have, the first thing is the result itself, the point of the result we need to compute. So this is going to be j, and which data point, which data, like the whole graph is, or let's say 0, 1, 2, whatever we integrated before, and then here we put I, because this is related with the data point. That's it. Basically, this is it. Return, well, US, XS, and SS, and shift enter. I will rerun it again because I recorded last in before, so I'm just repeat, like read, like the memory itself, just run the whole thing. It's yeah, the C didn't change, so we have the same thing. So here, okay, let's do it. So US, everything, these values, let's run it. Let's calculate the whole data here. Of course, we can pass these values, or we can just keep them as is, because we already default them into this shape. And let's print the shape, or print us.shape, xs.shape, and ss.shape. So what we find here is it's 11,000 data samples, and XS is also 11,000, only one value, and SS only one value. Of course, if you want to go to just print the whole thing, just to understand how it, I really think you have to understand how the data is structured. So we can see here the US, this is the first curve, this is the second curve, this is the third curve, and goes on. Of course, 0, 0 is just a start from this point, but it's just the curves. Now, this is the US, like how the US looks. If we see the XS, we will find that it's just the location of the points here, XS. And the SS is going to be the corresponding values. One thing I noted is actually when we print X here, it looks a bit, or it looks strange. So actually what I did is just try to print every element, and here print basically, or not, in for I in X S print basically I, and we can see here it's a really strange values. So the reason is we put here im plus 1. It's not plus 1, it's plus j. So it will repeat, well, im like every the beginning it will be 0, and it will keep adding the j locations, and then the other, when this become 2, it will become 100, and then it will be 101, 102, and so on. So it's my mistake. Now it looks nice. Now it looks normal. So here we can see even X is just normal. This is how it should look. It should be escalation of XS, and it's really good that we checked. Always it's good to check the actual values of these networks. Here seems also good, but the biggest indicator was actually the X itself.